pH and pOH indicators. This one's always a good experiment. I've done this one with my daughter. The purpose of this one is to gain an understanding of pH and how it relates to concentrations of strong acids or strong bases, to make solutions with series of pH values, and also to observe the pH range of several commercial or natural indicators. So there's a lot of background. Note that pure water, even distilled pure water, is actually slightly acidic due to the contaminants such as CO2 and whatnot. You don't have actual completely neutral water. Since the concentrations of the solutions in the center of the table are very small, contaminations may swamp the HCl or the NOH in these wells. It's more important that you're aware of the relationship between acids and base concentrations and the pH than it is to get an ideal pH value of in this section of the table. So good pH values would be obtained for the entire table if buffer solutions were used, and we'll be doing an experiment on that one as well. What you're going to need is hydrochloric acid, sodium hydroxide, some universal indicator strips. I think that would be, is this my universal indicator strips? There it is. I think that's this one. In fact, it gives you a little, let me open this up. Don't drop these all over the place. But here's your universal indicator strips right here. I'll show you in just a second. They look like that. And it gives you a little table that goes along with that. So put the table right here. And we'll just kind of, well, we don't need a whole lot of these. We'll just put some of them on the side. All right, and you also need your, wait, where is it? The phenolphthalein test indicator strips. Is that these? No, that's a, oh, here they are. Phenolphthalein test paper. A little bit different from your universal indicator strips, and also some bromothymol blue. There it is. Bromothymol blue actually ends up looking like bromothymol maroon, but I was thinking, oh, it's a blue solution, and so I was starting to look at this, but I was like, no, that's copper. Copper's always blue. All right, so what we're going to do is we're going to use the dropping bottle to put 5 drops of the hydrochloric acid into wells A1, B1, C1, all the way down to F1. So I'm going to go from A1 and I'm going to go down all the way down to F1. All right, here we go. 5 drops. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2. 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. You might want to go a little bit slower than that. I've gotten pretty good at these, but make sure you're exactly precise. All right. Put a few milliliters of distilled water into a small beaker. So, where is my distilled? Oh, here's my distilled water. I need a small beaker. This will work. Actually, this will work better. There we go. Okay. With a clean mini pipette, that's the one with a really small top, put 9 drops of distilled water in all of the other wells in rows A through F. 9 drops. Oh, okay. All right. So I'm going to put 9 drops of distilled water in A all the way through F, and from 2 to 12. That's going to take me a long time. Actually, wait. This mini pipette, I think, is broken. Yeah, let's use a different one. Mini pipettes, where are you? Okay. Here we go. There we go. Sorry. Excuse me. There we go. There. I got a couple of them. Mini pipette. Okay. 9 mini pipette drops in each of them. Let's suck up all of this water. We'll get as much as we can. All right. All right. I'll tell you what. Give me a second. I'm going to work on this. All right, I'm back. And actually, no, I didn't finish it. Sorry. All right, I'm back. And I'll be honest with you, that was a long, tedious process. So what I have here is I have pure hydrochloric acid in column 1, A1, A1, B1, C1, D1, E1, F1. And I have pure water, distilled water from A2, B2, C2, D2, E2, and F2, and then all the way up to 12. So I've just got pure water in there. Now, this is the tedious part. You're going to take, what is it, 1 drop? All right. With the clean mini pipette, put 1 drop from A1 into well A2. There we go. I'm going to put the rest back into A1. So I put 1 drop in to from A1 to A2, and I put the rest back in A1. What I'm going to do is I'm going to slowly dilute this across the board. So I'm going to mix it up by going into well A2, sucking it up, pushing it in, sucking it up, put it in. There we go. So I just kind of use my pipette to swish that water around, make sure it's nice and mixed. Now I'm going to dilute that again. So I'm going to take well A2, and I'm going to take up some. I'm going to put 1 drop into A3, and then I'm going to put the rest back into A2. Now I'm going to mix that up. There we go. Perfect. And then do that again. I'm going to take 1 drop. Now I'm going to repeat this tedious process. Oh wait, I didn't get any. There. All the way till I get down to, well, A6. And go all the way there. Okay. 1 drop. Put it in A5. Put the rest in there. And then just go all the way down. Yeah, I'm almost done at A6. Okay. I'm going to not go to A7. So what I did was I have pure hydrochloric acid in A1. And then I put 1 drop from A1 into A2. And then whatever excess I had in here, I put it back into A1. So now I have a clean pipette. Then I take this A2 and I take the contents and I swish it around like this. And I put it back. All right. Then I repeat that where I'm going to take 1 drop from A2, or I'm going to take some from A2. I'm going to put 1 of those drops into A3, and then I'm going to put the rest back into A2. Then I'm going to take my pipette and swish around A3, and then go and do that for all of them. And then what you're going to do is you're going to go and do that all the way up to A6. Now, that's going to take a long time, and I just did it for A's. You have to repeat that same process for B, D, E, and F. Now, the wells in A7 have only distilled water in it, and that's good. What you're going to want to do, don't touch this. We don't need to add any water to that. All right. So from table 1, we can see the concentrations of NaOH. Let's see. Here's table 1. So I have table 1. My concentrations of NaOH need to start at, concentrations of NaOH must be at 10 to the negative 2 in column 12, and a pH must be 12, or for a pH to be 12. You need to put 1 drop of the sodium hydroxide into 1 drop from a mini pipette into the water in each well of this column to reduce the concentration to 10 to the negative 2. Remember that a drop from the mini pipette is half the size of a drop from the bottle. All right, so they didn't really say this, but what I'm going to do is I'm going to go to well H12. Now, I'm not using any of the stuff in here on the bottom corner. I'm only using this top part. So I'm going to use some kind of other random well that I know I'm not going to use later. I'm going to put like 3 drops. 1, 2, 3 of pure sodium hydroxide. And then what I'm going to do is I'm going to kind of use that as a container for my sodium hydroxide, because what they want me to do is to use this mini pipette and fill up this thing over here. So I need to put 1 drop from the mini pipette into the water in each well of this column. So I'm going to put it into 12. So I'm going to take out the pure sodium hydroxide and put 1 drop from the 1 there, and F. Perfect. So I did 1 drop from A12 to F12. All right. Now, what we're going to do is we're going to do the same thing we did from A1 all the way up to A6, but we're going to now go from A12 and go backwards down to A7. So I'm going to take 1 drop from here, put it into A1 or A11, and then mix that up. Okay, then 1 drop from here, put it into A10, put the rest into A12, and then mix it up. I'm going to take A10, 1 drop into A9, then put the rest back into A10, and then mix it up. It's a long, tedious process. Not only are you going to have to do that for A's, but you're going to have to do that for... Are you going to have to do that for the rest of them? All right. Continue with columns 10, 9, 8 until you have the concentrations that match the table. Okay. Wait. With a mini pipette, put 1 drop from A12 to A11. Mix this by drawing it into the pipette, as you did with procedures 1 through 6. A11 should now have a pH of 11. Continue this from A10, A9, and A8. I made a mistake. I told you we're going to go all the way down to A7. That's not true. A7 is just going to have pure water in it. Don't touch it. Don't mess with it. What we want to go is go from A12, 11, 10, 9, and 8, and then stop there. Don't put any bit of sodium hydroxide into well 7. All right. Now what we're going to do is we're going to use the universal indicator strips and to measure the pH of each well in row A. So I'm going to take 12 of these things and I'm going to put them over here. Cut into... Okay, so I'm going to take 12 of these things, I'm going to put it into here. Just dab it, and you'll get a little thing like this. So let me just show you real quick. I'm not going to do all of them for you, but I put it in A1. I'm also going to try it in A12, and I'm going to show you the difference. So you can see that there is a difference between those two. What I would do if I were you is I would take a piece of paper, which I don't have on me right now. I'd take a piece of paper and I would put this down, allow it to dry, and then put a little piece of tape on the end that's dry still. And that way you can kind of lay out this thing, and then I would make sure to take a picture of that paper and put it in your lab report. Now let me just put this over here to let it dry. And what you're going to want to do is you're going to so we did A, and we used up all of A using these test strips. Now let's try this phenolphthalein test paper. I know this one's a long video because this one's kind of involved. Alright, I'm going to try going one on each side. In fact, what I'm going to do is I'll probably just rip off a small piece. Put this one here. Ooh, look at that. You see that pretty color? And I'll put this one in here. Rip off that small piece and put this one in here. See what happens. Oh, look. No color. Huh. Interesting. There's that cool little color right here. And no color with the other one. Interesting. Alright. And the last one is I'm going to use bromothymol blue. This guy right here. And I'm going to put 1 drop. Is it 1 drop? Of bromothymol blue. You know what? It doesn't tell you how many drops. So I'm going to put, I'll let you decide how many drops to put. I'm just going to put 1 on each end and show you, hey, look at this. Whoa. Don't do what I just did. I spilled out some of the hydrochloric acid. Oops. Let me see. Look at this. I just put 1 on each end, and you can see, hey, there's a difference in color. You see that different purple versus the different yellow? Anyway, you're probably going to get a nice little rainbow thing going on. You can also use other natural indicators. I've done this one with my daughter. She really likes this experiment. What you can use is red cabbage. We took red cabbage, we cut it all up, and then we boiled it. And then after we boiled it, we let it cool down, and we use a coffee filter to filter out the red cabbage so that we only got the liquid, and we tried it with that. And you end up getting different colors. It's really cool. I definitely want you folks to experiment with it, try it out, tell me what works. Some people say, hey, you can use flowers and dissolve the flour down in some rubbing alcohol, and then you can make a different indicator solution from that. Or beet juice. Any kind of dark vegetable will work real well. Anyway, this stuff is not too potent. What you can do is you just dump it all inside the sink at this point. Plus, the chloric acid will mix up with the sodium hydroxide, and that will kind of cancel it out if you dump it all out in one time. It'll make a nice, pretty, colorful, swirly thing inside your sink. In my experience, it's not permanent. You definitely don't want to have it hanging out there too long. To be honest with you, this experiment is a bear to set up. But, no, I don't want to lose those. Alright, this experiment is a real beast to set up. But you understand how to do it, and so basically it's just a matter of time before you're able to kind of finish the whole experiment. Do the cleanup, do the lab, answer the questions, do the lab report. I'd recommend highly that you take lots of pictures of this particular experiment, and that way you can kind of get a nice good record of what you did and include those pictures in your lab report.